Now, after that, we have found the accuracy scores for each of these splits. Let's calculate the mean of the 5 volts. Okay. To do that, we just can, call the function mean, np.mean, for the cross validation. Let me just start with typing. Find the mean of accuracy scores for the model on 5 splits using cross validation. Do that, simple as that. We just can call the CV. Okay, and then we'll assign it to np.mean. We'll set the variable or the accuracy, and let's print it now. See the mean. Okay, so this means that in our case that the accuracy across the 5 folds approximately is around 84%, indicating the overall average performance of the model on 5 different splits is equal to 84%. Okay, this information helps us to understand how robust the model is across different subsets of the data. A higher standard deviation means that the model performance, has significantly across different folds, can do, a higher performance. So next, after that, we have found the mean of the accuracy scores using the cross validation. Let's now try to find the precision. Find the scores. Okay. Well, okay, using cross validation. Do that, we just can, call a new value called we'll again use the cross validation score. Set our best params X and use Y dataset, and the cross validation has to equal again to 5. But this time our scoring is gonna use the precision. And let's also try to find the the mean. So you can just get the mean directly. Well, let's see first by calling this one, then modify the code. So on the first fold, it has around 78%, then we have around 89%, then we have again 89%, then we have 87%, and then we have around 72%. Let's find the mean now, so we can is equal to mean. Let's set our CV position. Let's now print that again and see what are the mean. Okay, around 82%. If you recall that without the cross-validation, our scores were higher than during the cross-validation. We have around 89%. Okay. So this is how we found the precision, scores using the cross-validation with a mean of 82%. Now, next, let's find again the recall. And to do that, let me type here, find the recall for the logistic, okay, based on cross-validation. Do that, again, we're gonna create a new value. Let's do it in that way, so we can save some time. So we have let's call this one as recall. Okay, let's change this one to recall. Then we'll change this one to call. So we have to change these, and then this one. Let's run that and see what are the, okay, as 92%, that is good enough. Okay, so the last one, let's do the F1 score. Let me do this one here. Copy and paste. Mean of F1 score. Same thing, let's call this one as F1 or C cross validation F1. And then let's change this to F1. F1. 1. See now the mean between the precision and recall using the cross validation. It's around 87%. I know it's hard to read, so let's try now to visualize it. Do that, let me just this. Is the course using cross do that, we're just gonna call it as cross-validation metrics. And let's save it on our data frame. Let's call it as pd dot data. Save all of these in data frame, so we can just visualize the data frame itself later. That let's put our main values. The first one is accuracy. That has to equal to okay, and then we have the let's say the precision. It has to have it we have the recall. It's gonna store the CV call. Lastly, we have the F1 score. One, set the index. Okay. So 0. Close now. Hopefully that we haven't made any mistakes. So okay, position. Now let's plot it. See plot. See it on a bar shape. So let's call it as cross nation creation with the legend. False. Okay. Now we can just call the plt.show